electron-electron repulsion take place. In a stable configuration, the electron-electron repulsion takes place, and as a result, the nuclear pull becomes ineffective. The nuclear pull becomes ineffective. As a result, what will happen? There will be a slight relaxation in size, means the size will increase a little. So, what is the trend across a period? The size keeps on decreasing because shells are not added, but nucleus is becoming powerful. So there is a decrease in size. You can see the size 152, then 112, 88, 77, 70, 64. Size decreases. And at the end, when we come to the inert gases, there is a slight relaxation in size. That is, the size increases a little. Now what happens down a period? When we move down a period, down a group, what happens? The electronic configuration, you can see written over here, hydrogen 1, lithium 2, 1, 2, 8, 1, so on. What is the effect of atomic size? What happens to the nuclear charge and the number of shells? As you are moving down, the number of shells are increasing. Is it or not? See, second period 2 shells, third period 3 shells, 4 shells, 5 shells, 6. So number of shells are increasing as you are moving down the group. Suppose this is group 1 elements, hydrogen, lithium, sodium, potassium, rubidium, cesium. The shells are increasing, so the size of the atom is increasing. Now you'll say that the nuclear charge is also increasing. When you're coming down a group, what happens? You can see there is only 1 proton, there are 55 protons over here. But in that case, what happens is the nuclear charge, this takes a dominant position, means this overrules this. The number of shells take prominence. This is the dominant factor. And this nuclear charge is overruled by the number of shells. So what is the total effect that we see? That as we move down the group, the size increases. See, 37 pm to 262 pm. So which is the biggest atom? Cesium. Cesium. The biggest atom is cesium. All right, across a period, when you're moving across a period, let's consider this, across a period, here, see, across a period. What if we are moving across a period, then what happens? The number of shells remain the same. Here, atomic size. What happens to the atomic size is it keeps on, see, number of shells, lithium. What is the number? What is the atomic number of lithium? 3. So electronic configuration of lithium is 2, 1. Beryllium is 4, so it is 2, 2. Then it is 2, 3 for boron. So in this way we see that as we move across a period, the number of shells remains the same. 2, 1, then 2 second distinguishing electron enters the same shell. And the third also enters the same shell. So what happens is the number of shell remains the same. That is, the atomic radii remains the same. Because the shell number is not increasing. So atomic radii will remain the same, no impact on the size of the atom. But what happens is, with each, as you are moving towards the right, the nuclear charge is increasing by, the magnitude of the nuclear charge is increasing by 1 count. See, here the number of protons is 3, the number of proton is 4, the number of proton is 5, and so on. So the nucleus is becoming more and more strong. It's becoming stronger to attract the electrons towards itself. As a result, what do we see? We will see that there is a shrinkage in size. As you are moving from lithium onwards, here lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, as you are moving towards the right, we see that the size decreases. Why does it decrease? Because the radii remains the same, the differentiating electron is entering the same shell. In the second period, it is entering the same shell, that is, it is entering the second shell only. But the nuclear charge is becoming more and more stronger. Means the number of protons progressively increasing. The number of protons are progressively increasing. As a result, what will happen? The nuclear pull will become stronger and stronger. The nuclear pull will become stronger and stronger. And a gradual shrinkage in size will take place. A gradual shrinkage in size will take place. So as we move across, let's see this, 1, 5, 2, then it keeps on decreasing. As you can see, the atomic size is decreasing up to this, up to fluorine. It keeps on increasing, 64 only for fluorine. But then at the end, we have inert gases. Group 18 is inert gases. So what happens at the end? There is a slight relaxation in size. Why does this happen? Because of electron-electron repulsion. Because the octet is complete in the last shell, the octet is complete. In noble gases or inert gases, the octet is complete. So as a result, what happens? Overcrowding of electrons is there in the last shell. It is 8 electrons in the last shell. As a result, electron-electron repulsion takes place. And when